Teresa facilitates the reusability of security and dependability patterns when developing new applications in resource-constrained embedded systems. This presentation describes the tools used to accomplish this task. Teresa technology includes a repository to store models. A model represents a specific aspect of a field of knowledge. It is an abstraction of a program specification and is often represented as a diagram. Models are composed of linked artifacts. Each artifact represents a characteristic of the model. It can be a name, a property, a relation to another model, and so on. A repository is a storage facility that allows the creation, update, and retrieval of models. Engineers who use the repository have a separation of roles. The pattern engineer's objective is to create reusable subsystems. He develops patterns for security and dependability using pattern editing tools. They allow for the creation and storage of engineering artifacts, which are the blue balls in the picture. The pattern integrator's objective is to ensure that the patterns can be used in the development of applications in a given domain. She uses pattern instantiation tools which transform the repository artifacts into a form that is adapted to the application development environment, which are the red balls in the picture. The creation of reusable subsystems involves the specification of process models used in the application domain, and models of security and dependability patterns. There are two parts to creating a Teresa metamodel. One is the modeling of the current engineering process, and the other is the modeling of the adaptation of the Teresa process to the current engineering process. The model of a process includes phases and activities, plus tasks and steps, as well as checkpoints and tools. A process is composed of different phases. Each phase can be composed of various activities. For instance, hardware architecture design and software architecture design are two activities that compose system architecture design. A checkpoint can be a review or an audit to end a phase or an activity. Activities are composed by sequential and/or parallel tasks. Steps can be used to refine the description of a task. Products are also used to highlight the tool chain and the possible work products resulting from different activities. A model enables the clear identification of the step where a pattern can and must be involved to raise the trust in the resulting system. The model of a pattern is used to represent and store the knowledge of an existing solution to a problem that is often encountered in a domain or company. The Teresa project defined a domain-specific modeling language to model patterns. A pattern model is composed of internal interfaces that implement interaction with the platform, external interfaces that enable interaction with the rest of the application, properties that are security or dependability properties provided to the application, constraints that are requested features from the platform to guarantee pattern properties, static structure that represents the architectural structure of a pattern, for instance by a class diagram, dynamic structure that represents the behavior of a pattern, for instance through a sequence diagram. The pattern integrator needs a tool which provides the following features: the capability to browse patterns in order to find one that fits a specific engineering domain practice, as defined in the process models. The capability to select a pattern from the repository. And the capability to export the pattern in a format used by the engineering domain practice such that it can be imported in the tool chain and allow its instantiation in the system being developed. Teresa has implemented the following tools: the repository management tool called Gaia, the process editing tool called Naravas, the pattern editing tool called Arabian, the properties constraints editing tool called TKO, and the instantiation tool called the Rhapsody Converter, which is the access tool developed specifically for the railway and metrology domains. Gaia, Naravas, Arabian, and TKO were developed by IRIT. The access tool was developed by Trialog. Teresa stands for Trusted Computing Engineering for Resource-Constrained Embedded Systems Applications. Teresa is a project supported by the Framework 7 program of the European Commission.